Okay, we've gone and swapped the meters out and just put two jumper leads in there. As the meters were hooked up, I've kept the diodes in place. On the output, I've used the two lowest value resistors I have, 1 watt resistors, and they're 4.7 ohms, and they both read, using the 1 meter there, 4.7 ohms. That's the lowest value I have, and they're just plain old resistors. I know a dirty way of doing it, but we must get some sort of idea. So that's the scope placed across the resistor, which is hooked to the negative side of the circuit. Any current in there, of course, has to pass through that resistor. So what I'm doing is eliminating any errors that the meters might have been reading. I've also turned the voltage up to give her a bit more power. As you can see, the LEDs are a lot brighter now, and on the 1 meter that I have left across the blue LED, we're putting 17.91 milliamps into that. Like I said, the input on the negative side, ground side, 4.7 ohms, and I have a 4.7 ohm resistor, exactly the same resistor across the green LED. So our scope is just about zeroed at the moment. Right there, I'm set on 0.1 volt on the divisions for our voltage, and not that that really matters, but 5 microseconds for our time divisions. So I will turn the scope on. Now I've kept the probe so it's the right polarity, so this pulse on the top side is the pulse we will see when I hook the scope here. So we'll be reading both top pulses. The bottom one, of course, is the other side. So that's what we have at 0.1 volts. We'll get a kick up to about 2.2 or 0.22 volts, and then it comes straight back down, levels out at about 0.1 of a volt. Now I'm guessing these little kicks you're seeing are the coil being switched back and forwards, the original current drain from the coil, or maybe the LEDs firing up, I'm not sure. Still learning about this. But that's what we have on the input side as far as the scope across that 4.7 ohm resistor is concerned. So of course when we switch over this resistor here, we are only going to see this top pulse and then the flat line at 0 volts. So that is why I've hooked the scope around that way. So when I hook the ground onto the negative side and the probe onto what would be positive, will be on the top as well, so we can compare the two. So once again, that's what we have. So I'll now take the probe off of the input resistor and place it, as I said, across the output resistor, and that is what we now have. We are peaking at about 0.32 volts and comes back to 0.2 volts and settles down to about 0.15 volts across that resistor. And as you can see, same time on the pulse input as it is on the output. So that was just another way I decided to check the input and output. Like I said, they're not calibrated shunt resistors, but they both read 4.7 ohms. They're both exactly the same resistor. Must give us some sort of indication as to the input and output across that one leg. Also keep in mind, got the LED running after that resistor as well. So just something else I thought I'd throw in there. And probably actually looking for an accurate way to measure this. Now dual channel scope would be good, but there's going to be problems with the ground side of the scope if it does not have an isolated ground on each channel. The way we're doing this, we'll end up with a short. So one problem we've got to try and get over. But as far as the voltage across the input and output resistors, that's what we have. Cheers.